My name is Peter Nikolov. I'm Chief Technology Officer for Opsani, and I will tell you about continuous optimization as a service. First, a few words about me. I have been building cloud infrastructure from the early days of cloud before it was even called cloud, but I have also used cloud for many different applications and for many large systems at scale. I have co-founded Opsani, where our mission is to improve cloud operations using machine learning. I want to share a war story with you, something from that we were helping a customer complete their digital transformation. So the customer was a large online event and video conferencing provider. They moved from their on-prem data center to the cloud. They were fantastic. They finished that in just a few months, which is amazing. It was a really happy and successful experience for them. They were a poster child for DevOps. Their developers were carrying pagers, just operating their services, had really the power to do what they needed and bring features quickly. It also allowed them to expand their market. In addition to the larger companies that they had as customers, moving to cloud allowed them to move to smaller customers where instead of a whole server, they could use a fraction of a server. And that is something that cloud enabled to them, for them. But it did bring in its own problems. And before I go into the problem, I will tell you the answer is 7.5 quintillion. So let's see first, we will return to this, but let's see first what the problem was and what their experience was when they were onboarding, especially on the smaller accounts. So their developers will build the code for their application. They would deploy it, run through different environments, following best practices. And then once they put it in production, they would notice performance lags. They needed to be able to share the same node between multiple customers, having different amount of resources, but sufficient to be able to operate. So of course they did the thing that everybody does. They started monitoring real user performance. They started building load generators, synthetic load generators, and they started using complicated APM tools that were able to get high visibility into the performance of the application, and with very significant amount of work to understand why the performance is what it is and try to tune it. Of course, that takes a long time. So in the meantime, the solution is over provision. Give it more resources, hopefully that you will get enough performance. And you do by putting a lot more resources than what your application needs, you will able to get that higher performance. And then with more kind of in-depth analysis of the data, things that were taking pretty much 6 to 8 weeks at a time, they were able to feed back into the testing process more details, as well as to development, which on the surface sounds good, but when you realize that one of the benefits of cloud is moving to DevOps and to high velocity, they were having releases every week. So if it takes them 6 weeks to optimize a release, you understand that they are significantly behind on that. So the result was that they ended up over provisioning a lot, and then they put a lot of work into manually optimizing these services, and they were always looking back. So this is kind of like driving on the freeway by looking in the rearview mirror. So let's look at an example. How should this work? Or what is exactly the problem? We'll use as an example the online boutique. It is a reference application that Google built to demonstrate best practices for microservices and generally help people understand how to use Kubernetes. So this is an e-commerce application. It consists of 11 different services, and you see them here on the diagram that work together. And then if you want to, and it's a good example of any application that you, probably most applications that you would want to deploy. Now, if you want to put this application into production, you have to tune it and make sure that you can reach the performance goals and work with the number of customers that you have, and you need to be able to handle the performance you need it. So it is an 11-tier application, and it comes pre-configured with certain parameters, certain parameter values as their defaults. And if you just deploy it like that, you're probably wasting a lot of resources, and you don't know if you're meeting your performance objectives. So when you look at the configuration, what is that configuration? There are two configurations per service. That is the CPU and the memory. And again, that is a very simple case. Most applications have a lot more. They may have Java, you may have network configuration, kernel parameters, and so on. So there may be a lot of other configuration, but let's just focus on these two. Even if we decide that there's only 8 possible settings for the CPU and for the memory value on these 22 different parameters, you end up with 75 quintillion different configurations that you may use, and only one of them is the optimal. So what does this mean? 75 quintillion, okay, we have computers, they can do that quickly, right? Well, if you compute that, you will see that at 100, if you can try 100 different configurations every second, which is hard, you have to run a lot in parallel, but say you can do 100 configurations a second, it will take 23 billion years to complete and to go through the full space. And you really don't have that time, because only in 5 billion years, the solar system will disappear. And your business has even less time than that, because your development team releases a new version every week. So you really don't have that long. So what we did is we connected the online boutique to our continuous optimization service and decided to see what the actual tuning should be for running it in production. And the results were that we were able to trim costs to 79%, or reduce costs by 79%, and we were able to increase throughput more than 2x. The resulting efficiency was an increase of over 8 times on the number of transactions that it could do per dollar. Now, the most interesting part here, so first, this is by itself is amazing, but we were also able to do that with only 20 minutes of setup. One of our solution engineers configured it and connected it to our optimizer, and it took about 2 days to tune and get this result. And here we will show the dashboard, show you what our continuous optimization looks like in our product. So this is the application that we have optimized, the Google Online Boutique. And then if you look at the configuration, these are all the 22 different parameters, CPU and memory for each of the microservices. And you can see what their original values are as they came from the manifest from GitHub. So as our system went through a number of steps, it found an optimal value or optimal set of values. So it found the exact Goldilocks configuration that is exactly perfect with respect to meeting the performance objectives and not over provisioning, not adding too much resources. And then you can see the results in improved performance, significantly reduced cost, and then the efficiency in the performance cost ratio efficiency is improved. Coming back to our presentation, once you have continuous optimization as a service, how does this change the process? How does this improve the picture that I showed you earlier? Well, by adding continuous optimization in production, then you have real-time autonomous changes to the configuration and tuning of those configurations to match the current load and the current application behavior. And that is the core. This is the first thing, because that works immediately, that works on your production system, and it is working at the moment. It adapts to the current circumstances. If you like, you can also use that in your pre-prod environment or in performance test environments to shift left the performance tuning and see how this works even in development. So this allows you to start working with performance even earlier. So the result of this, of having autonomous workload tuning, is that you have higher performance, lower costs, and actually what we have observed is also better stability. So what is continuous optimization as a service, and where can it be applied? It can work on a single application. You can attach it to one service. If you have you have one SaaS application and that's your main app, you can attach it to that. Or if you're a larger company, you have a service delivery platform where all of your applications, all of the development groups run their applications on that platform. You can attach it to the platform as a whole and work with all services. So it scales to thousands of services, and that process is autonomous. It onboards all the applications that it finds on the platform. And then what the tuning that happens continuously. It happens every time when there's a new code release. It happens when the load profile changes. You have different customers or different mix of requests are coming. Or if you have an infrastructure upgrade, let's say you use new machine types, different cloud providers, different third-party libraries. These are all things that can significantly impact the performance of your application and how it behaves and the resource use that it has. So on each of these changes, optimization can be performed, and it will tune it to the specific circumstances. And then the value that it delivers continuously is the higher performance, better performance, more stable, improved availability of the application, and lower cost. So the result of this is, and you have probably seen this in your own projects, is that manual workload tuning just doesn't work anymore, not at these speeds, not at the sizes of projects that we have. We have weekly or even daily releases, so the frequency is so high. Their applications are running on multiple different platforms and have immense variations of different configuration settings, many tunable parameters, many things that affect the performance and the cost. So combining all of these things, if you try to do this with manual tuning or not tune, then you can only work reactively to improve performance. It is really hard to get to good results and know that you are actually not spending too much money. So I hope I was able to show you that manual workload tuning in today's environment is just impractical. Our systems and my applications change too often. They run on a variety of different platforms and have very complicated configurations. The result is that you can see massive waste of resources, poor performance, and as a result, also lower availability. With continuous optimization as a service, you can outperform your competitors because your applications are always tuned. You can outsmart them because your developers are spending more time building features instead of tuning and doing trial and error adjustments. And you can obviously outlast them because you have to use your resources more efficiently.
Hello, my name is Mark Jimenez, and I am a technical marketing engineer at Opsani. To recap Opsani application optimization, Opsani optimizes runtime settings such as CPU and memory at the cloud level, and in-application settings such as garbage collection time and database commit time. Opsani optimizes in production by instantiating a tuning instance, a code copy of standard application instances, learns about application performance, and uses that data to tune runtime settings of the standard application instances. So after optimizing application runtime, CPU, memory, and application settings, what can we optimize next to drive towards fully autonomous application operations? The Opsani Learning AutoScaler takes the same scientific, data-driven approach and applies it to autoscaling. We're starting with Kubernetes and are replacing the Kubernetes horizontal pod autoscaler. What Opsani generally does for optimizing runtime, that is, read metrics, learn, then intelligently apply runtime updates, the Opsani Learning AutoScaler now does for autoscaling. The Opsani Learning AutoScaler machine learning automatically learns periodicity and trend of an application's traffic pattern and application behavior to scale up and down for the best service level objective performance at the least cloud cost. In this topology, we are generating traffic to two instances of an application. First, to a static 15-pod configuration, and second, to a configuration that is autoscaled by the Opsani Learning AutoScaler. The first graph shows the traffic pattern, which is the same for the 15 static pod configuration and the Opsani Learning AutoScaler configuration. The second graph shows the scale. Of course, the 15 static pods are always at 15, but with the Opsani Learning AutoScaler configuration, we can see how Opsani autoscales the number of pods against the current traffic level. Most of the traffic graph follows a normal sinusoidal pattern. But if we zoom into this time frame, we can see a traffic spike. In less than a minute, the Opsani Learning AutoScaler configuration scaled this application from 4 to 11 pods. The third graph shows the P50 and P90 response times. We can see that for the given traffic load, the Opsani Learning AutoScaler configuration calls for less pods than the static 15-pod configuration. Let's look at a different comparison versus Kubernetes autoscaling. Out of the box, the Kubernetes horizontal pod autoscaler scales at a defined CPU percentage utilization target. In this comparison, the Opsani Learning AutoScaler configuration is receiving the same traffic as two other configurations, one with a 50% CPU utilization target and one with a 75% CPU utilization target. Because the Opsani Learning AutoScaler has learned the periodicity and trend of traffic, versus reacting to a CPU percentage number, the Opsani Learning AutoScaler configuration predicts traffic and application behavior, and as a result, scales up faster than the CPU utilization target configurations. We can see that for a 50% CPU utilization target and this traffic, that max scale at 10 pods is more than we need than the 8 that Opsani has autoscaled to for a little over an hour. This means that without Opsani, you are spending more than is needed to maintain a near 200 milliseconds P90 latency. One might think that if 50% is too loose, that bumping up to 75% might be better, right? Well, the 75% CPU target configuration in this case does run one less pod at local peak here. We can see that for about 15 minutes, we've gone way over our 200 milliseconds P90 latency target. One can ask, so why don't you set the Kubernetes horizontal pod autoscaler at 65% then, and be happy? The answer is that at what CPU percentage utilization target you have to configure to meet the same service level objective varies from application to application, and the ideal CPU percentage utilization target can even change when your code and third-party libraries change. Multiply this by the number of applications and their varying traffic levels, and you'll quickly see that intelligent automation is the only way to manage the chaos. With the Opsani Learning AutoScaler, you'll never have to worry about retuning the Kubernetes horizontal pod autoscaler for code changes and long and short-term traffic pattern changes. Opsani not only considers metrics that are more relevant to application performance, the Opsani Learning AutoScaler learns traffic patterns and application performance and intelligently and autonomously scales for you. Let's go over the benefits of using the Opsani Learning AutoScaler versus the Kubernetes horizontal pod autoscaler. The Opsani Learning AutoScaler is more intelligent, applying machine learning to traffic periodicity and trend, and service level objectives to intelligently autoscale at the lowest cost. It's faster. With the Opsani Learning AutoScaler, there's no need to worry about connecting to metrics or the pipeline. Simply point the Opsani Learning AutoScaler to your deployment, and it will automatically replace the horizontal pod autoscaler, configure the metrics gathering, and start autoscaling. Because the Opsani Learning AutoScaler has learned traffic periodicity and trends, it's faster to scale to increasing and burst traffic rates. Finally, the Opsani Learning AutoScaler is automated scaling ops that embraces production chaos. Through code changes and traffic pattern changes, there is no need to reconfigure or retune the Opsani Learning AutoScaler. For more information on how Opsani can autonomously tune application runtime settings and scale, reach out to us at Opsani. We're happy to help you achieve automated excellence.